Hello everyone and welcome to this presentation on Android Automotive Monetization Made Simple. My name is Saverio Labella and I am a principal software architect at Harman Automotive. Harman is a wholly owned subsidiary on Samsung Electronics. At Harman we design and engineer connected car products and solutions for automakers, consumers, and enterprise worldwide. This includes connected car system, audio and visual products, enterprise, automotive solution, and services supporting the Internet of Things. In this session, we will explore the untapped potential of the automotive market for Android developers. Learn how to adopt your existing mobile and tablet apps for the automotive environment, leveraging the unique opportunities for monetization and broader market reach. This session will guide you through the essential of Android Automotive OS, the difference from projected solutions like Android Auto, and the tools and resources available to streamline your app development process. You'll discover how to navigate the publishing process, utilize payment APIs, and meet developer recommendation for a successful entry into the automotive app market. Let's talk about Android Automotive. The Android Automotive system will be available in 70% of vehicles by 2030. This unlocks multiple benefits for you as Android developer. You can now bring your apps into an increasingly software-centric automotive market, extend the reach and visibility of your apps and your brand across devices. You can now bring your app into the vehicle and create a seamless home-to-car experience across devices. You can monetize automotive customers and create new revenue streams from your apps through subscription and in-car services, which are set to explode with the emergence of interactive displays and pervasive connectivity in vehicles. And all of this is easy. You can use your existing Android skills and resources, which can save you both time and money by using code and components from your Android apps for phone and tablets. Let's take a look at the history of Android Automotive. It all started in 2014 when Google revealed Android Auto, which mirrors up from your smartphone onto your car infotainment system. In 2017, we saw the introduction of Android Automotive. Unlike Android Auto, Android Automotive is a full operating system running directly on the vehicle's hardware, without relying on the smartphone, so providing a more integrated experience and a seamless one. The next major release came in 2018 with the announcement of the Polestar 2, the first car with built-in Android Automotive. In 2019, Google developed and opened the Android Automotive API for the developers, third-party developers, which allowed for more and robust app development for the car. And fast forward to 2023, we reached a significant milestone with the integration of the Harman Ignite store with the plug-in Android solution in the Audi A4. 2024 marked the launch of the first car with Android Automotive and the Ignite App Store in front of the customer, the Audi Q6 e-tron. Android Automotive OS, or AAOS, is a base Android platform that runs directly on the car. It runs system and also third-party Android application. At HAL level, the most important addition is the vehicle HAL, which abstracts the vehicle properties. At framework level, the standard Android services are unchanged. The automotive version adds the car service, which handles the car-specific interfaces and exposes the VHAL properties to third-party application. If we look at the application level, at system level, the main application are the car system UI, which has no back button, that's important. The car launcher, which has no default support for standard widgets. And the car AMA, which implements the keyboard and is blocked while driving, for example. AAOS has two main system apps: the car media that renders the third-party media templated apps, and the automotive host that renders the car templated apps. Third-party applications have three main categories: audio media application, car templated application, and parked apps like video, games, and browsers. Now let's look at the difference between Android Automotive and Android Auto. Android Auto, which is depicted in the diagram above, provides a driver-optimized app experience for Android smartphones on a compatible car system. The Android Auto renderer connects the audio media and templated apps and renders a driver-optimized surface that is shown on the car. The main app UI running on the smartphone is still defined and rendered by the developers. In Android Automotive, however, everything runs in the car. The audio media and the templated apps do not render the UI, only via templates through the automotive host. And parked apps like video, games, and browser, however, can directly render the UI while the car is in parking mode or on the passenger display. This link provides an overview of the style-related difference between Android Automotive and Android Auto. Let's look at the media audio apps. The media audio apps like Spotify are the first third-party application which have been added to Automotive. They use the media template API and are rendered by the car media app, which is customized by the car manufacturers. The most important component of an audio media app is the media browser service. Standard activities, for example, for settings and login, are allowed, but it is not allowed to set them as distraction optimized. If you have to implement them, please consider to use the car UI library. The physical buttons are handled directly by the car media app, and if you want to simulate the car knob or the steering wheel controls, you can test them by injecting the key code media pause or play via ADB. The media browser service is also accessed, as you can see in the diagram, by other system components like the VPA, the voice assistant, or the car launcher widget. So it is important that the on-get root of your service allows app holding the media content control privileged permission. Let's talk about the VHAL. The vehicle HAL defines more than 240 properties, but most of them are protected by privileged permission. The car properties are exposed via the car property manager. An application can read, write, or subscribe to a car property. Third-party applications can access 50 properties shown in this table, which are covered by normal or runtime permission, like, for example, car model, speed, fuel, and EV connection type. Only 4 properties are mandatory, so it is recommended to check the properties if the properties are available before accessing them. The car templated apps uses template defined by the Android X car app library and are rendered by the automotive host, which is customized by car manufacturers. The library defines around 10 templates, for example, the list, grid, message, pane, navigation, and is used by both Android Auto and Android Automotive OS application. To target Android Automotive, you have to include an additional library that injects the car app activity in the app. It's called the App Automotive library. The car app activity needs to be added in the manifest and can be set as distraction optimized. Once the application is started, the car app activity provides a surface that is used by the automotive host to render the template models. In case of automotive, there is no need to add a list of allowed signatures, since the host validator library in the library allows the host, which owns the car template renderer privileged permission. On the Harman Ignite platform, you can optionally include the Ignite CarApp library that adds additional templates like the one shown below, for example, the Explore, List Details, Route Overview, or POI streaming. The CarApp library started as a closed-source GMS library for Android Auto. The current stable version is 1.4.0, released May this year. Yeah. The app has to declare the minimum API level to be supported in the manifest, and the Automotive host supports a range of library versions and handles back and forward compatibility by negotiating the API level to be used with the app. The Ignite Automotive host launched with the level C, so library version 1.3 support, but now is supporting API level 7, the 1.4 version. Application should check the negotiated get car API level before using the new features like tab template. An app can verify if the host supports the Ignite templates by checking the host info. In the following slides, we'll present you the Harman Ignite store. Harman's strong relationship with car manufacturers and established expertise in in-vehicle infotainment position it as a leading supplier in the automotive industry. Through our Ignite store, we provide developers the options to join a full AAOS-compliant platform, providing tools, SDK, API, and detailed documentation for easy integration and migration. Via the payment engine, developers have access to a variety of monetization mechanisms, including paid app download, subscription, and services. Upon registering with the Ignite store, developers gain access to the developer portal documentation, enabling them to set up reference images and SDKs. Ignite emulators can be easily set up via Android Studio. We support AAOS images starting from Android 11, and moreover, the emulators have additional support for camera APIs, system UI, runtime resource overlays, instrument cluster, multi-user, and starting from Android 14, multi-user and multi-display support. The system UI runtime resource overlays allows for easy integration and emulation of specific OEM displays and system insets, as shown in the image above. You can see different emulators with different insets. So that's the same emulator running with different options. Our Artifactory, moreover, provides Vim3 and tablet images running Ignite software with reference AAOS implementation based on Ignite for download. You can also easily integrate our cuttlefish images into your CI/CD pipeline. Let's move to the app publication workflow. The journey from development to a live app involves several stages. First, the developer submits the app to the Harman Ignite Store platform with all the necessary information. Then the app undergoes the Ignite Store certification, a rigorous QA process to ensure it meets all standards and performs reliably. After QA, the app moves to the auto OEM, which is the car manufacturer, review stage. This is conducted, for example, by CARIAD for the Volkswagen Group. This review checks compatibility, safety, and performance. Finally, the developer publishes the app, making it live on the Harman Ignite store. Users can then download and enjoy the app, enhancing their infotainment experience. This process ensures that all the apps in the Harman Ignite store are of the highest quality, maintaining a robust ecosystem of reliable and innovative apps for Android Automotive. Let's talk about the monetization opportunity with the Harman Ignite store. The Ignite Store comes enabled with payment features empowering developers to monetize their apps. Developers are now able to offer their apps as paid apps. The payment SDK exposes API for goods and services, in-app purchases, and also subscriptions. Developers can also integrate their own PSPs to sell goods or services and receive the money directly in their bank account. For a frictionless in-car payment experience, we also provide a dedicated digital wallet app for end users to securely store their credit card information. Our payment processor is powered by the industry-proven Samsung Checkout. So let's move on to discuss some of the technical aspects and challenges involved in developing and integrating those apps into our platform. Not all the car uses the Google Play services. So you have to check if the GMS libraries and functionalities are available. For example, the fused location provider is not available. To get the location, prefer to use the standard location manager APIs and don't assume a location provider, for example, the network provider, is available. In case of geofences, starting from Android U, the system itself reports geofences support. For older Android versions, we recommend using a foreground location service as a fallback. For the navigation intent, so if you want to start the user to navigate to a desired location, please use the car context action navigate with the standard geo schema, which is defined by the RFC 5879. If you're developing a navigation app, however, consider also supporting the Q and Z extensions. Regarding the camera, you can use the Camera 2 APIs with lens facing front or back. And starting from Android 13, there are specific automotive camera type, like sit row, left, center, right, that you can use. Please consider also the driver's seat location to understand if the passenger is on the left or left side of the car. Regarding the voice API, be aware that not all the cars support text-to-speech, speech-to-text, or the voice interactor API. For voice integration via the VPA, not all the voice assistant can handle, all the voice assistant can usually handle common intents like starting the application or going to the application preferences. Media commands are usually handled via the media browser and media controller interfaces. So it's the media app from the car manufacturer which handles them. But for advanced voice integration, you can leverage the built-in intents, which have parameters defined in shortcuts XML and deep link fulfillment. Automotive allows for get parking facility and get charging station, but in the future, get thing could unlock additional use cases. If you are developing parked apps, keep in mind that in AIOS, there is no back button. So while developing the UI, you have to consider also the screened instance and the different insets that may vary from car model to car model. Even on the passenger display, consider that user has to extend the arm and is subjected to vertical vibration. So you can reuse your tablet or mobile phone app, but you have to apply still some changes. For example, the minimum touch size should be at least 7060p. You should minimize the animations, but you should anyway give visual touch feedback. The contrast ratio for the icon, text, and images must be at least 4.5 to 1. The most important thing is to handle the audio focus. You need to handle the audio focus if you require audio in or out. In Android Automotive, you can even use the WebView-based application. And if you are using WebView for video, consider that the WebView implementation handles correctly the audio focus for you, but if you have other elements in the HTML for audio, those are not handled. So your application should request the focus instead of the WebView. Finally, if you have to develop the UI, please prefer the car UI library, which is set to be the standard. Yep. So here you can find some helpful resources for the Android Automotive car UI guidelines. Regarding the future trends and innovation, if we talk about the car app library, the version 1.7 is still beta, but we think it will be released soon, and this will add new templates. It will improve, moreover, the ability to manage and develop applications that combine templated and parked activities. Regarding the car UI library, the car manufacturers are starting to adopt OEM plugins for it. This will allow the OEM to customize the look and feel of your car UI library-based APK without having to generate package-specific runtime resource overlays. Now, regarding AI and machine learning, expect car manufacturers to embed on-device small language models and offer similar capabilities and API like Gemini Nano. Finally, please expect standardization for non-GAS, so Google, app stores. Examples are the payment, places, and navigation info API. The target is for third-party developers to compile a single bundle using a unified SDK, enabling the app to work flawlessly across various car models and app stores. Today we are hosting the CodeLab session, Create an Android Automotive System App with Payments via Samsung Checkout. This CodeLab will be a complete development guide for AAOS templated application, showcasing a shopping app that performs goods and services payments via the Ignite Payment SDK based on Samsung Checkout. Developers will learn how to implement templated apps using both AAOS and custom Ignite templates. Moreover, developers can be able to do purchases. The app will be integrated with the system navigation and expose built-in intents, voice search interfaces. That's some screenshot. We invite you to explore the Harman Ignite Store Developer Portal today and join the app ecosystem building the future on in-vehicle experience. Thank you for your attention. I hope this presentation has been informative. The CodeLab is still open till 5:30. Please don't hesitate to reach out if you have further questions. Thank you.